Hey folks, welcome back. So in the last episode we started working on our interaction interface and just the overall interaction logic that we are going to be using within the game. In today's episode we are going to continue with that logic. So where we left off is we had generated a line trace. We do want to finish off the rest of this logic here, and then we're going to want to create some actors that use our interaction interface so we can actually trigger this properly. So what we're going to do now is check to see if our line trace actually hit something. So if line trace was it LT hit dot be blocking hit, and just like everything else, we're going to use the negative context. We are just going to return our line trace didn't hit anything, but if it did hit something, we are then going to see if actually we can do that up here as well. If it didn't hit anything, or if it did hit something, and LT hit dot get actor implements U interaction. So what we're doing here is if we didn't hit anything, or if we did hit an actor and that actor doesn't use our interaction interface, we don't really care about it. However, in that case, if we did hit something, we are going to want to interaction interface pointer inter equals lt cast to an I interaction interface lt hit dot get actor. And then just like before, if inter equals null pointer, we have an issue here. We're going to just return, and we can do add logging. Actually, we don't need to do that. We've covered that now. So we're actually going to add that in here. We're going to go include logger.h, and here we're just going to go logger dot semicolon get instance add message, not dot, it's error, add message failed. Something I like to do actually for clarity. Let's go that so we know what function failed to cast to interaction interface. Error level, and this one is an error. So assuming all of this has gone through, we have an interface pointer, it's all working there. What we then want to do is oh, sorry, I missed some code here. So if we actually want to store a pointer to this actor, so we are going to go back here. We want a visible one, not an editable one. A actor pointer interaction actor. And we want this to initially be a null pointer. We don't want a value there. So back here, and we already know if we haven't hit anything or it doesn't implement the UAction interface, what we can do here is if interaction actor does not equal lt hit dot get actor. Actually, do we need this? It was a Yes, that was if we're changing. So if you move slightly, like a pixel to the left, and you hit a different one. Oh, no, no, I see what I was doing. Sorry. I was looking at old code here that didn't quite make sense. And this is why, like I mentioned in my introductory video, I'm restarting this series with the dev diary basically on that, or restarting the project as this series with the dev diary. Is I'm looking at code that I wrote 8 months ago and it doesn't make any sense to me, or some of it doesn't make any sense. So anyways, okay, so we have got the interaction interface, but we need to do this in a slightly different order. So if interaction actor equal to null pointer, or interaction actor does not equal lt hit dot get actor, interaction actor equals lt hit dot get actor. And actually, this is where we want to go up here. We want interaction actor equals null pointer. So just to walk through what we've done here quickly, and also basically to make sure it makes sense in my own head, we are checking if we didn't hit anything, or if we did hit something but it doesn't have the interface. We're clearing out our interaction actor because it means we're not looking at something that we want to be able to interact with, and then we're dropping out of the function. If neither of those conditions are true, so we are looking at something that does have the interaction interface, we're checking to see if it is if we don't have a reference, we're going to set it, or if it's a different actor, we're going to set it. Actually, we don't even need to do that. That is a if check we don't need. We can refactor that out. We can just set it directly. We don't need to worry about that. And then we don't need to keep referencing the LT hit. We just use that there. So, and this is some of the refactoring and refinements that I do normally. I will write some code, reread it, and as some people may know, rubber duck debug it. And then in this case, there wasn't a problem, but I'm reading it and I'm like, well, actually, I'm doing a lot of stuff I don't need to do here. So all right. All right, and then so next thing we want to do is we need to add a function that's going to be a blueprint native function to our player character. We're going to go down here, U function blueprint native event. At least I think this is one. Let me double check. I may have the wrong one here. Oh, my code can be all over the place. Nope, this isn't the blueprint native one. This is a private one. So what were we doing there? Update pickup text. Oh, that was a refactoring I can do. So yeah, we can leave this as a blueprint native event. Void update pickup. Sorry, we want this update interaction text. So this is something we will be implementing in blueprints once we get back into the editor. Because yeah, that calls toggle, and that is that. So yeah, we do need obviously the implementation version of this as well. Define that, and this is one of the, what are you doing? There we go. And we just want to call update interaction text, the blueprint version. So we have the basic functionality for displaying information to the player character. We do need to add in now a action for interacting with things. So we're going to go to our input section. We are going to just grab any of these U properties because they're all identical. U input action pointer interact action. And then we need to add a function for that. So we're going to go down here, void on interact. And we're going to create that definition. So we're going to add this to the player input component first of all. So we want enhanced input component, bind action, interact action, e trigger event. Now this one, you don't want to use one of the repetitive ones like triggered. You want to use either started, which is when the button is first pressed, or completed when the button is let go. Personally for this, I prefer to use completed because then you can push the button down, hold the button down, move off an interactable item, and then let go of the button, and it's not going to do anything. So this, and then we want a TF player character on interact. So we've added that there. Now we want to add some really basic functionality. So it's if interactable interaction actor is equal to null pointer, return. Now we can potentially refactor this. However, well, and I'll finish that thought before I move on to the don't. We could refactor this and have the interaction actor as a pointer to the interface. I personally don't like doing that, though in theory it should be a more efficient method. I rather not do that and just do the little cast here, just out of my own personal preference. So we want I interaction interface pointer inter equals interaction actor. Actually, we want to cast that, sorry. And we can go fix up our line trace in a little bit, I believe. I think we're grabbing an interface we don't need to. So let's actually fix that up here. So if it doesn't, yeah, we don't need any of this. Actually, before I do that, we're going to copy that because that's actually exactly what we need for down here. So we're going to replace this. And we're just going to fix that logging. So just to explain what I do here with my logging quickly, I just put in, oh, missed the A, the function. So this tells me the class and then the particular function that was called that threw the error, and then the actual error. So anyways, we've got that now. So what we want to do here is inter.interact implementation. And then in this one, we have its calling. Well, we need to pass in a character. Now, the reason for this, I will only cover this briefly. We're actually going to cover more of that when we get to the inventory component of things. But the reason being is we are passing along the character, in this case, the player character, that is making the call so that the object that we're interacting with, if needed, can say, okay, add me to your inventory. So we're just going to pass in this. And that's all we need to do for that one there. So we're going to build this, make sure we have no errors. And typical fashion, this is taking a little bit of time. So I will pause the video and I'll be back as soon as the build is done. Okay, folks, so the build has finished. You can see everything has succeeded. Also, while this was building, I did go through and actually add a asset pack to my project. In particular, this is the one I added. The reason I added this, as you guys can probably guess already, it's doors. This is a very basic interactable that you can add to a project. And really, it's a core one used in pretty much any game, be it a fantasy game, a sci-fi, modern survival. And this right here gives you a breakdown as to why you get door frames and the individual doors. So you can set these up in a couple of different ways, and that's actually going to be one of the things we cover now. So with that, we're going to launch the editor, and this time around, I'm not going to be launching it through Visual Studio. I'm actually going to be launching it through the Epic Launcher. So hopefully this doesn't take too long to build or to launch. But with that, I'm actually going to pause the video quickly just while things launch, because this may take a little bit as I did add that asset pack in. All right, folks, so the editor did take a little while to launch just because we were launching it from the Epic Launcher and we added in those assets. And just to show you, this is the asset pack here we added in. Doesn't apparently match up. Volume 8 in the marketplace, but volume 7 here. Either way, you can see we have a bunch of mesh. So I just want to check. Let's see. I just want to check something here before I go and delete it, because we don't need the nanite mesh right now. And honestly, these we will probably be replacing. This is just a simple asset pack I could find. Okay, they do use mixed. All right, so I'm just going to leave those for now. Anyway, so what we're going to do here, we're going to open up our project folder. We're going to go into the blueprints, and I'm going to create a new folder in here and just call this dev. I'm going to capitalize that with an underscore at the front so it stays at the beginning. Blueprint class, actor, BP door base. So the reason I'm using this naming convention is I want to create basically a parent blueprint that we're going to use for, well, that in theory could be used for multiple different doors. So what we're going to do here, open this up. And this is, as I mentioned, we could do this in C++, and I sort of want to. However, ultimately for what we're doing here, it's going to be overkill. So the first thing we want to do, though, is we want to go to our class settings. Over in the interface section, we want to add interaction interface. Compile that just quickly so it loads all of that in. And then you can see here on the left-hand side, we have 3 functions, which are the ones that we, and I'll just bring them up here, the ones that we outlined within our interface. Get interaction text, interact, and is interactable. So minimize this a second. Is interactable, interact, and get interaction text. So static mesh component. This is going to be door frame. Make that the root. And then we're going to add another static mesh. And this is going to be the door itself. So I'm going to do here, I'm just quickly hop over to these mesh. We're going to go for the low poly. And just for ease, we're going to use this single door here. And let me bring this back. And I'm going to move the content browser out of the way. So the door frame, we want to use that mesh I just selected. And then for the door, we're going to add this one here. And this is one of the reasons why I wanted to use this particular one, at least for this phase, is I've used it in the past. We switch over to rotate mode. You can see the pivot point on the door is where the pivot point should be on a door. You will find there is some assets that they're not created to be movable, dynamic like this, where you'll end up with the pivot point sort of in the middle of the door, which is not the best. So now what we need to do though, we want to go to the is interactable. We can just double click on that actually. We want this one is interactable. So we want to have that default to return true. We don't need to do any fancy logic for this one here, but if you wanted to, you could set up like, oh, is the door locked? Things like that. Get interaction text. Well, we want to actually have open or close. So we need to actually add a variable for that. So we're going to go down here, scroll down, variables, just a Boolean, B is open. And then what we do is drag off here and just do a select text. This is being slow. So connect the is open to the Boolean input for pick A. So what this is if it is open, we want to say close. And if it's closed, we want it to say open. And then finally, we want to double click on the interact. Now, this is going to bring it up as a custom event within the event graph because it's not a function. I'm just going to bring up the Visual Studio again quickly. And we're actually going to go to the header file. It's because this is a void that has no return type. It automatically gets created as a custom event. So what we want to do here, we want to go right click timeline. If I could spell, add a timeline and door rotation. Double click on that. We want to pick our length. We're going to say it's going to take 1.25 seconds. Use the last keyframe. We want to do that. New track, add a float track. We're going to call this Z rotation. Shift click twice, once to the front, once to the beginning, once to the end. Click the first one, change that to 0. So the time is 0, the value is 0. Hit enter, helps. And then click on the last one. We're going to put the time at 1.25. And just quickly before we finish this off, actually, go over to your viewport, select your door. Make sure you're in rotation mode and then just see, okay, 90, we want this to open to about 110 degrees. So go back to your timeline, click on that last one and set the value to 110. We can close out of that timeline now. Close out of this and this, stay in the event graph. So we want to start off by grabbing B is open, drag off, put not. And you want the not Boolean, which is up here. Then we want to set that. So what we're doing is it's a flip-flop, but for the Boolean. So if this is true, we're going to set it to false. And then we want to drag off a branch. So if it is open, we're setting it to false, which means we're going to be coming through here, which means we want to reverse. Now you can reverse from end, But what that's going to do is if you, and you may have seen it in some games, if your door is partway open or close and you interact with it again, it jumps to the end or the other position and then starts completing that action. So you just want play in reverse. And then in this, going through the other flow though, so if it was not open, we're going to be setting it to true. Set this to true, it's going to come through up to the true. We want to do that. Now we want to take our door, drag off a reference to that, set local rotation. Sorry, not local, relative. Set relative rotation. It's right there. I'm blind. Split your struct. Z rotation goes into here and move this to update. Compile. Now, what we have done here is created a very basic door that can be open and closed. Actually, we want to set this back to 0. That's its default state. And I'm just going to bring that blueprint over. We're going to put it up here on that, and I'm going to rotate the whole thing 90 degrees. Now, we can't actually do anything with this just yet. It's actually not going to work because we do need to work on our third-person character and their input actions. So bringing the content browser open, we're going to open our input folder. Into our actions, we are going to duplicate the jump just because it is a one push. So IA interact. We are going to go back to our default mapping. We are just going to add in that one we've just added, IA interact. And in this case, now, again, this is going to be down to how you want your key bindings set up. Ultimately, I do want to add in what is the character lean, like the left-right lean, pretty common in FPS, like shooter games. However, oh, I forgot to disable that. However, we're doing a survival game, but so instead of using the more common E for interact, I'm actually going to be using F. We're going to save that. And we just need to hop into our actual blueprint, interact, and just add that there. And for now, I'm going to leave these, the debug 7 and 9 for save and load, because they are actually going to be useful for us. But so first things first, now we're going to play. You are going to notice we're not going to be displaying any text. That is expected. We haven't set up that portion of the UI. And you can see because we do have that the Boolean trigger for should we trace set to true by default. You can see we're here. We're not doing anything. So we're going to have to launch in the editor there. But let's move away. And you can see now that we moved away from that, it's working. We get closer. Oh, I'm hitting the wrong key. Well, that's still not doing anything. So let's stop here. We're actually going to open up that door blueprint a second. And we're going to add a breakpoint on there just to see, does that actually trigger? So I'm going to move that off the screen. And if it does trigger, I'll bring it back. So let's see, we're going to go through, our line trace is there, we have to fix that. Go up, hit F, it is not triggering. So let's check character, here, enter. Okay, it is, we have it referenced, but we're not triggering it. Okay, so let's close out of the editor because we want to run this through Visual Studio. I should have done that in the first place. We'll quickly look over our code just to make sure I haven't messed something up there. So, setup player input component, bind action, interact action is on interact. Okay, on interact goes if the interaction actor is a null pointer, return. If the interface is a return. Actually, I'm gonna just while we're doing that. I know why, because we're calling the implementation. And in here, it doesn't actually call anything, so interact. We'll just do that. So this would be why. We're calling the C++ version of the function. Why are you... oh, caller. I need to pass that through. We are calling the C++ version, but it doesn't point through to the blueprint version. So that is, I'm like 99% sure that's why that failed. So we're just going to let this build and launch the editor, and I will be back as soon as that's done. All right, folks, Visual Studio compiled, and we're now back in the editor. Let's actually see if this makes a difference. Now that I've fixed the fact I'm calling the C++ version and not the blueprint version. Forgot to fix that, but that's not a problem. So we'll run over to our door, hop up here, and then hit our interact button. There we go. Now, oh, we got a null pointer. Okay, let's go through. Break that one. I wonder why that's happening. Interaction actor. That's the first time I've seen this particular issue. Maybe it is because it is a blueprint. Okay, so anyways, let's go character. Make sure. I'm just gonna, nothing else. So that is, oh, we've got it in there twice. That doesn't help. Let's see. Goes away once. Put them both in. To check that one. So it does hit there, but we're not getting an interface. So let's look at the blueprint. Well, we've got the interface, interaction interface. It should be, well, okay, well, maybe this is going to be, it's the first time I've done it using purely blueprints. So I will go through, we're going to go to our C++, public base classes, new class, actor. And actually this is going to go back to our save game, actually, because this is going to be something that is down to your individual project requirements. But for mine, I want the state of a door, whether it's open or closed, to be saved. So we're actually going to create a base actor class in the same way we created that base character. And then let me get back into the, this is going to take a moment here. Come on, open it back up. It's still adding it in, so this may take a moment. But anyways, I will go back to what I was saying. So this is going to be dependent on the sort of game you're wanting to make. I know a lot of games don't save the state of a door, be it open or closed, because that's a lot of information to save for very little return. However, that is something I want to include in my game. I want, like, if you leave a door open, I want it to save that you left that door open. without going into specifics, because it's something that's going to be much, much later in the series, there's a reason for that. So, okay, we're going to let this live code finish as well, because we want to create a second class here. But to further continue what I was saying, so we're going to create that base actor class, in this case TF actor, which we're going to use to be a parent class that has all of the save game logic on it. And then from there, just like we did with character, if there's anything additional we need to add, we can either derive TF actor or we can spin off something different. So actually, we don't need to worry about the live coding finish because we're going to shut down the editor right away anyways. So no, we do, because we need to be able to make a derived class. So anyways, continuing with that. So what we'll be doing is we're going to create a very quick TF actor base class that is going to inherit from the interface. We are then going to create a derived class of TF actor, which is going to be door base, and that's going to be don't want texture filtering. What we're going to work with for a new door attempt. TF door actor. Nope, we want TF door base. We'll create that class. Wait for this to finish. Hop back over to Visual Studio. Hopefully it says you want to reload. Yep. So we're going to... Can't stop it there while it's running, so we've got to go into the live code. Wait, cancel out of this. Go back to the editor itself. Okay, move the browser out of the way. Thank you. I'm going to close out of the editor. Close out. Thank you. We'll wait for Visual Studio to stop debugging. This can take some time, it seems. I'm going to hit reload. And this may take a moment to populate all of this. But the whole purpose for this and the derived actor class is, as I mentioned with the character, it's for things like the stat line. Instead of having to add it to multiple different classes that are all going to be doing the exact same thing with it, you start with your base class of TF character, and then you do a derived TF player character. Then you can also derive like TF animal, so you can have an animal base class, a zombie base class, a mutant base class, a dragon base class if you're doing fantasy, things like that. And then anything that is used by all of the actors or all of the characters goes into the TF character, and then anything that's unique to a particular class goes into their specific. So we're gonna we can get rid of character, keep those two, and get rid of player character here. And we need to open the door files because it didn't open those for us. So we're going to start off just here. We're going to include that in TF actor base. Actually, nope, we don't want to include that. That's in door base. We want to include the save actor interface. And I went to the header when I wanted the source. So I'm going to put this TF actor here. And we're just going to go public save actor interface. Grab those quickly. We need that one. Let's bring these down here. That one. I personally, well, actually, no, you could have runtime spawned actors. So we've got get actor ID, set actor ID, get save data, and then we should have a set save data. Do we not have that? Oh no, because we haven't had to do any custom information on a actual actor yet, so that's why. So we'll go back to, I'm going to actually close these all out. We'll go to the actor. So up here, we just want to add fguid save ID. Go into here and just go save ID equals fguid new GUID. And same as we did with our TF character, if save ID is valid, change that to not, save ID equals fguid new ID, new GUID. And we'll create these implementations quickly, or definitions, I should say, implementations. Talking and reading at the same time does seem to mess with my brain a bit. Did I already create that one? No? Why are you not letting me? Oh, that's why it's missing that semicolon on the end. Okay, so we want this to be return save ID. And then same as before, if save ID dot is valid, save ID dot invalidate, save ID equals new GUID. Now, right now we don't have anything we want to include with the get save data implementation, and we're just going to leave this one basic because that is going to vary from child class to child class. So we've got the very basics here set up for the TF actor. We're going to save that and close out of these. And now we're going to add the door setup. So we've got that in here. So we want public interaction interface. Add these in quickly. So private, just because I know we're going to have some variables there we want, and public. And finally is interactable. So we're going to quickly define these. Okay, so right now we're just going to, again, default this to return true. For this one, we are just going to call the interact with caller because, again, this is something we're going to do through blueprints. I personally hate trying to do things like timelines through code. It's simply easier and more elegant to do it at a blueprint level. So we'll deal with the get interaction text though. So we're going to add in a U property visible anywhere blueprint read write save game meta, no, it's a lowercase meta on this one, equals allow private access equals true. That's actually an inconsistency I dislike here. Meta is spelt with a lowercase. However, where is it? Save game. Save game? Nope. Save actor interface. That was it. Oh no, that was the stat line. Sorry, I forgot where I'm putting enums. Where I've put enums so far. If we look here, umeta, it's all capitals. That's just personal preference. I dislike how name convention isn't consistent through everything. Anyways, I digress. So we want this to be a bool. B is open. We're going to say false is the default state. So now we have that. We can go back to this class here. Class this function. B is open. If it's open, we want it to say close. And if it's closed, we want it to say open. Const character f text. I can never remember how you declare text. F text. From string. That's it. So just to quickly run through this, I actually need to go through and create a constructor as well, but the way we set up here is if the door is currently open, so if this is true, we want to return this value, close. If it's false, we want to return this value, open. Let's just create a constructor real quick. We don't primary actor tick can tick, can ever tick. We don't need the door to tick, so we're just going to set that to false. And that is also something I would recommend doing. You can do this both through a code level and through blueprints, is if your actor does not need to tick, and what that is being in, like, the actor does not need to be told every single time the frame has updated, turn it off. The fewer of those that are around, the better. It is far more efficient. So let's build the project. And I know this episode is running on a little bit, but I will finish this up before I end the episode. So what I'm going to do is I'm going to pause things here, and I will be back as soon as this has built and I've launched the editor. All right there, folks, we're back in the editor now. So first thing we're going to do, just for ease, I'm going to delete this from the scene. We don't need that. Save the scene. And then we're going to go over to our content browser, going to go into our dev blueprints, and we're going to delete this one here. We don't need that. Yes, it's referenced in memory. However, I removed it from the scene, so that's not a problem. Blueprint class, all classes, TF door. Select that, and BP door base. So I'm going to try this again. Open it up. Same thing as before, static class, or static mesh. That is the door frame. Static mesh, and this is going to be the door. Let's save variables. Why is it? Is open. I thought I had that set to blueprint read write. Did I put read only? Oh, door base. No, blueprint read write. Oh, there we go. Yeah, that's a weird one. It's not here in the variables on the left. It's not editable in the details panel because it's only visible anywhere, but we can get and set within this. So go back to the viewport. I'm just going to move content browser out of the way. I'm going to use the exact same door I used last time, the low poly mesh. Bring this back up, door frame, and door. Actually, I'm going to just compile and save this, and then we're going to see if we're running into the same issue as last time. Rotate this 90 degrees and play an editor. So I will fix that. But, okay, let's see. F. Okay, interaction actor is the door. We've got the interface this time. So it was something with how we were casting to the blueprint to get it. It might be this. I actually have never worked with that before. I'll do some digging on that between episodes just so I can see if I can figure out why. But anyways, we're going to continue here. So Do not directly call event function in interface, call execute interact instead. And that is where close that. That is in here. And that's this line. So it's enter. What we want is enter, execute, interact. This. That's why. All right. 2 few arguments, and I think it's this I actually need to call. U object. Comment that out, save, and minimize this. So we're going to go back here. Actually, because we're going to do a live code update, I'm also going to clear character header file. Enable ray trace. This is going to start as false. Just to fix that now. Back to the editor. We're going to do a live code update. This should not take too long because there's only those 2 minor changes to the player character. Apparently 3, but that's because it's the game mode is referencing that character. Successful. Okay, so we're going to go back to our door blueprint now that we've done that. Interface is interactable. We're returning true. Get interaction text. Get inter. That is open. I'm just going to set it up here as well, just in case. Now, right now, we don't need to worry about that if it's open. So, yeah, we want this as open. And if not, we want that as close. This seems backwards to the way we had done it previously. So if this is true, we want it to be closed. If it's false, we want it to be open. All right. And then the interact, which should, there we go. So close out of these two. Is open. Get is open. Is open. Set is open. Not Boolean. Branch. And we want a timeline. I probably could have just copied this over for ease, but door rotation. If it's true, we want it to play. If it's false, we want it to reverse. We want to go in here. We want to set this to 1.25. We want to use the last keyframe. Float track, Z rotation. Shift left click, shift left click. The first one wants to be 0, 0. And the second one, we want it to be 1.25 and 110. Compile that. Close out. And then we want door. Set relative rotation. Split this struct pin from the update. We want to bring that over. Compile, save. Close out of that. I do apologize that it seems I am in a bit of a rush. Just this episode is running a little longer than I'm used to. So I want to try and... Okay, so there you can see we got close enough. The line trace starts. And it stops as we get away. We get to the door. We hit F. And... oh, we need the interaction actor. So yes, this is why. So with that though, folks, actually I'll quickly cover this issue, but we're going to end the episode here shortly. So I'm just going to stop debugging. We're going to go here. So this is the one I was messing up on. It needs to be that. So we're executing interact on this door, and we're passing through the collar. So, as I said though, folks, I'm going to end this episode here. Thank you for watching and putting up with my insanity in this episode. I know I've been a little all over the place. Next episode, we're going to finish up the last of this interaction and hopefully get things working where we actually see that door opening and closing. But thanks again, everyone, and I will see you in the next episode.